To the channel, and in this video we are going to talk about the Kubernetes interview questions part 2. So this video will consist of 10 questions, and these questions are related to the Kubernetes only. So we are going to discuss all these questions within 10 minutes one by one. So let's get started with those. First question comes as, what are core component of K8? So as you can see, I have already written the answer as well, because in the last video someone asked in the comment section only that it's good to have the questions, but it will be more helpful if you provide the answers as well in the written format rather than just explaining only. So I have written down the answers as well and questions as well now. So Kubernetes consists of the following core components. It is divided in the two parts: control plane, or you can say the master node components, which has the four components. As you can see, the Kube API server, main API gateway for the cluster. Like through this API server only you will be able to communicate with your cluster, correct? Then the etcd, which stores the state of the cluster. You can say a distributed key value store that holds the cluster state and configuration. Whatever the configuration you have made within the cluster, all the configuration and the state of the different jobs, the different config maps, the different configuration, all the things are stored in the etcd in the key value pair. Third component out of the master node component is kube scheduler, which assigns pods to run need. Like one pod is there which needs 1 GB of memory, correct? 1 GB of memory and some of the storage. So based on the requirement of the pod, it will kube scheduler will decide on which node it will get scheduled, correct? So that's the job of the kube scheduler. Then controller manager, which manage the controllers like replication controller, correct? So how many number of pods should get running, correct, according to the particular deployment. So that will be managed by the controller manager. If anytime anything goes down, the controller manager will check for the desired state and it will replicate the new pod coming up, and same goes for other controllers as well. The other component out of the worker node components are kubelet and kubeproxy. Kubelet is responsible for it ensures that the pods are running as expected. That means your pod is healthy and it's running, correct? Then kubeproxy is there, which handles the networking between the different pods, between the different services within the cluster. You can say handle networking and route traffic between services. So these are the two you can say the component: control plane, worker node components. And within the master node or the control plane, there are four components: kube API server, etcd, kube scheduler, controller manager. Then within the worker node, there is a kubelet and kubeproxy. So you can answer in this way: what are the core components of Gate? This is the architecture, you can say. Then next question is, oh, I just missed. The next question is, what is a pod in Kubernetes? A pod is the smallest deployment unit in Kubernetes. So when you talk about the K8, correct? Deployment file, daemon set file, stateful set file, config map, secret. Pod is the smallest deployable unit in Kubernetes, which runs your different containers, the different processes within it, correct? It represents one or more container running in shared environment. So one pod can run either one container or the multiple containers, 2, 3, 4, 5, how many number of containers you want to run, you can run. Containers inside a pod share networking and storage resources. So if a particular pod has 10 GB of storage, so the different containers can consume the different kind of storage. So you can define the different storage for the different containers. When we say the containers, that means your application, correct? How can you write YML file for your pod? That is over here, API version v1 kind pod metadata specification. So this one you can see, correct? So this is how you can write the YML file for your pod. Then moving forward, what is the purpose of kubectl or kubectl, you can say? Kubectl is the primary CLI tool for managing Kubernetes resource and interacting with the cluster. Here are a few kubectl commands you should be familiar with. So if you see in the first part we talked about Kube API server, correct? Main API gateway for the cluster. So you can communicate with your cluster with the help of kubectl command, or you can go with the K8 API calls as well. So this is one of the way kubectl through the kubectl commands you can interact with your cluster. So that's the purpose of kubectl. It's the primary CLI tool for managing Kubernetes resources. Moving forward, if you see the kubectl related commands, these are the basic example commands: kubectl get pods, kubectl get services. It lists the all pods, list all services, view logs of a pod. So these are the commands of the kubectl through which you can interact with your cluster. You can list down the services, you can do the modification, you can change anything, correct? Fourth question, what is a deployment in Kubernetes? A deployment in a Kubernetes is a higher level abstraction that manages the life cycle of pods. So we talked about the pods, that it is the smallest unit which is deployable in the Kubernetes, which runs your the different containers, correct? Deployment is nothing but it's a higher level abstraction of the pods only, correct? How pods will be managed, how much resources will be there, how many number of replicas will run for the particular deployment. So it ensures that the desired number of replicas are up and running and provides feature like rolling update, rollbacks, and self-healing. These are the features of the deployment. If you want to see the YML file for the deployment, this is the YML file, API version app/b1 kind deployment. In the deployment, kind is deployment. And then metadata specification, and all these are the configuration related things which you should practice while appearing for the interview, correct? Interviewer might ask you to write down a simple YML file for the deployment, for the daemon sheet, for the pods, anything, correct? So you should be aware of this as well. Moving forward, question number 5. Sorry, where is the 5? What is the deployment? What is a Kubernetes service and why is it needed? A service in Kubernetes exposes a group of pods and allow communication between and to them. So it's a service is a kind of like there are multiple types of service. We will be taking that question as well in the next one. But there are multiple services. If you have deployed your application and you want it to expose to the external world, you can expose through the help of service. If you want to make the communication between one microservice to the different microservice, you can create service and you can enable the communication between the different pods. So as you can see the definition as well, a service in Kubernetes exposes a group of pods and allow communication between and to them, correct? So pods can communicate with each other. When we say the pods can communicate, that means processes running in the different pods can communicate with each other. That means if there is one application and that has to get the data from some other application which is running within the same cluster, they both the services can communicate with each other even though they are running on the different pods, because we have enabled the services, correct? Which kind of services you can enable for internal communication and for the external communication, that we will be talking in the next question. Since pods are ephemeral, their IPs can change, meaning the application talking to the pods must also change the IP address. Services has the stable IP addresses, therefore provide a stable network endpoint with a fixed IP addresses, correct? That's why there is a service concept in the Kubernetes. Your pods are ephemeral, correct? So anytime if it faces any error, it will get restarted, the IP address will get changed. So if your application A is communicating with application B with the IP address 1.0 and the application B get down, now it has come up with 2.0 IP address, correct? Just for example. So your application A does not know that 1.0 is there or 2.0 is there. So service will be there which will route it back to the same application B, correct? Even though it's 1.0, 2.0, 3.0. So service gives a stable IP address so that you can make the communication between the different processes. Moving forward, if you want to see how service file can be written, it's the kind service, metadata, specification, selector. If you see, based on the selector, it will route there, correct? And which kind of services you can create? Cluster IP for the internal communication, correct? If you see, the IWAP service forwards traffic to the pods that have the label app my app. So it goes with the labels. The application which will have this particular label my app, the service will route the traffic there. So question number 6, what are different types of services available in Kubernetes? We talked about the services. So what are the different services? So there is I move to the next question. Let me come back. Cluster IP, node port, load balancer, external name. Cluster IP is the default one which allows for internal communication of the pods only accessible from within the cluster. Node port, this exposes the service on a static port of each node. So just suppose that your cluster has 5 number of nodes which are running. Like you have launched a node group and that node group has 5 number of servers running. That means the 5 number of EC2 instances if we talk about the AWS cloud. So with any of the public IP address of your EC2 instance, you can access this particular application which is running. Correct? It exposes the service on a static port of each node. So each node will have particular IP address, correct? With the IP address of that, you can hit the static port like on which your container is running, target port, and then a static port of each node, making it accessible from outside the cluster. So even though you are outside the cluster, you can hit the IP address and the static port, you will be able to see the application which is running. Then load balancer, uses a cloud provider external load balancer. Like if you are deploying it on the AWS side, it will launch a load balancer, AWS load balancer, and with the help of that load balancer, you can access your application which is running within the cluster, correct? Then accessible via public IP. The service is then accessible via public IP. External name is kind of mapping to the DNS. Like I do have a customer DNS called as ecommerce.com, abc.com. That can be mapped with the direct IP address of the node on which my application is running. The service is then accessible via public IP, correct? So sorry, the maps a Kubernetes service to an external host name. So the abc.com can be mapped with your IP address on which your application is running. So that's the external name. Moving forward, the question number 7. What is the role of config map and secret in K8? Config map stores non-sensitive configuration data while secrets stores sensitive data like API key and password, certificate related details like your certificate TLS private key, TLS your certificate data. All those things can be stored. The any database endpoint, database passwords that can be stored over here. The API related tokens that can be stored in the secrets. While config maps stores the different kind of environment variables, like you have to use the DB name, you have to use the DB host that can be done publicly. You can use the labels, you can use the variables like which environment you want to deploy, production, staging, test, QA, whatever the correct. So non-sensitive data can be stored in the config map, while the sensitive information can be stored in the secrets. Using secrets allow you to avoid putting secret information into your application code. In contrast, config maps will enable you to make your application more configurable. So with the help of config map, you don't need to put all the environment variables value in your code. You can create a config map value and you can refer that while doing the deployment. So it will fetch the value at the dynamically, and it will pass all the environment variables value to run your application, correct? So that's the use of config map and secrets. You can read about this. Let's move forward for the YML file of the config map and the secrets. So this is the YML file for the config map, kind config map, metadata and data, database URL here you can pass. While in the secrets, API version v1 kind secret, you should focus on the API version as well, correct? If you see API version v1 for the config map, for the secret, while it was app/v1 for the deployment. So you should focus on these things as well and the different syntax of this. While creating secrets, you need to pass the type, opaque or the TLS, whatever you want to create the secret, data, password. Moving to the next question, what are the question number 8? What are namespaces in Kubernetes? A namespace is a virtual cluster within a Kubernetes cluster, or you can say the segregation of the resources within the clusters. Like within one particular area, you have just created section A and section B, and then you are creating the different resources in section A and the different resources in the section B. So it's just a virtual cluster, you can say, or the segregation of the resources. It helps to organize workloads in multi-tenant networks by isolating resources within a cluster. You can find a shortcode snippet that shows how to create a namespace. So this is the command you can use to create namespace. kubectl create namespace dev, and it will create a namespace called as a dev, correct? Then moving forward, you can create the pod within that particular namespace. kubectl run nginx, you can run the nginx, and image you can use the nginx namespace dev. So within the dev namespace, this will run. It will not run throughout the cluster. It will not run in the different namespaces other than the dev, correct? But it will run within the dev namespace only. This nginx server will run. Then question number 9. What are the labels and selectors in Kubernetes? Labels are key value pairs attached to objects. Example, pods. They help to organize Kubernetes objects. Like you have 100 numbers of items, and out of 100 numbers item, you want to rate someone as a good, someone as a bad, someone as a green, someone as a yellow, different colors. So the different colors are kind of labels and selectors. How will you select, correct? So that's the way. Here is an example pod that has the label environment production and app nginx. So if you see, this pod has labels environment equal to production, app equal to nginx. Now you could use the following label selector to fetch all pods that have the label environment pod. So like you just get into the namespace dev, and within this namespace dev, you want that all pods should get listed which has the labels as production or the dev, correct? So you can run this command. Which command? This one. kubectl get pods namespace dev, and all the pods which has the label called as your dev, that will be listed over here, correct? Where I went, okay, yeah. So that can be listed. Now moving forward, what are the persistent volume and persistent volume claim, PV and PVC? That is the short term which is called eventual. So let's get into the definition over here. Persistent volume provide storage that persists beyond pod life cycle. So as we talked about, pod is ephemeral, correct? It can be restarted anytime due to certain issues. Here it can get in the crash loop state, it can fail, it cannot be available, your its IP address will change, the data can be lost, correct? So you have the concept of storage in the Kubernetes where persistent volume provide a storage that persists beyond pod life cycle. That means even though your pod goes down, your pod get destroyed, the persistent volume will be there, which will store all the data which has been written there while the application was running on that particular pod. How it will be done? So for that there is a PVC. So for every pod there will be PVC. It can be attached to one or multiple. That mapping is on yours. The PV is a storage piece in the cluster. PV exists in the cluster only, correct? It's on the cluster level. That's the interview tricky question. Someone can ask you that where does PV exist? So PV exists on cluster level, not on the namespace level, correct? That has been provisioned by a cluster administrator or dynamically provisioned using storage class. A persistent volume claim is a request for storage by a user. That means if there are 10 number of pods running, they all 10 pods can request from the PV that I need some amount of storage, and then your PVC will be created. Here is an example, PV and PVC YML definition. So if you see for the PV persistent volume, it is persistent volume, that's the kind. It has the specification as storage 1G and access mode read write once. That means data can be either read and write, both the things, correct? If you see the persistent volume claim, it has the specification access mode read write once. That means the data can be read over here, it can be write over here, and it has requested the storage 1G. So if the 10 number of pods are there and it has the persistent volume has 10 GB, so each 10 pods can request for 1 GB, 1 GB or 2 GB, or how, like, it all depends on how you want to distribute, correct? So that's the way you can use. So persistent volume stands on the cluster level, while PVC stands persistent volume claim stands on the pod level. It can request from the PV that how much storage it requires or how much configuration it requires to store the data. So this is all 10 questions I wanted to talk about in this particular video, and it's explained with the answers written. I hope it will help you to get started with the interview preparation for the DevOps or for the cloud engineer, for the platform engineer. So watch out the videos and subscribe to the channel to get more technical contents related to the interview preparation, related to your technical stuffs like AWS, Terraform, GitHub Actions, Jenkins, and other DevOps skill set. So subscribe to the channel. Till the time, thank you. Bye bye. Welcome to the channel, and in this video we are going to talk about K8 interview questions part 3. So our first question is, what is Kubernetes networking and how does it work? But before we proceed, let me tell you that these questions are kind of intermediate level, which will be beneficial for the one who is having the experience around 2 plus 2 to 5 and similar kind of thing. So let's get started with the first question, that is on the networking side. What is Kubernetes networking and how does it work? So Kubernetes networking allow for communication between pods, services and external clients, like the different DNS available or the applications which are available, correct? How the networking will flow from to and fro from the cluster. So if you see, there are 4 pointers how the pod to pod communication will happen. Each pod gets a unique IP assigned and can communicate within the cluster. Second point is service to pod communication. Services provide a stable network endpoint for a group of pods. As pods are ephemeral, that means whenever a pod will get restarted, its IP address will change. So service will give you a static IP address through which you can the network can flow. Each pod gets a new IP assigned every time it is created, correct? So with the help of service, they can communicate in a better way. Third one is ingress controllers manage external HTTP or HTTPS traffic. So with the help of ingress controller, you can route your traffic to the different ingress and moving forward to the different services, and then it will go to the pod ultimately. Fourth point is network policies. So when we talk about the network policy, so here we define that how the network can be either either communicated into the different namespace, or if you want to restrict the communication into the different namespace, like within the one cluster you have multiple namespace A, B and C, and you want to restrict the communication from A to C. So with the help of network policy you can restrict that as well. Moving towards the second question, what is role based access control in Kubernetes? So it's called as a RBAC as well, role based access control. So it's a kind of security mechanism that restricts user and service based on their permissions. It consists of role and cluster roles. Define the actions allowed on resources, like what kind of action you can perform, get action, your modify action or delete action, write action. So all those kind of actions are defined over there. Then we do the role bindings and cluster role binding. Assign roles to user or service accounts. Like we used to create the service account, and the service account will have the binding with the cluster roles, and with the help of that your application will communicate, and will be able to communicate with the different services which are of your cloud services or any of the different objects within the Kubernetes cluster. So this is kind of your YML template, you can see. So these are kind of permission within the verse, get, watch, list. So these actions can be performed, and who can perform on the resources, on the pods level, this can be performed. So it's if you see the name of the YML, so it's a kind of pod reader. So you can get, you can watch, you can list. Moving forward towards the third question, this YML you can go through, but let's move to the third question. How does Kubernetes auto scaling work? When we talk about the Kubernetes auto scaling, we are talking about if traffic goes on the higher side. So how your Kubernetes will behave, correct? How the pods will behave, how your number of node or worker nodes will behave. So if you want to auto scale up and down in number of pods, so you can enable your HP, horizontal pod auto scaler, and that will adjust the number of pods based on CPU usage, memory usage, or custom matrix. Like you define certain threshold or the number of inputs, and based on that your number of pods will increase for a particular microservice, like whatever the configuration you passed according to that. Then you can enable your VP as well, that means vertical pod autoscaler, that will adjust the CPU and memory request for the individual pods. Like you have one pod running for which you have allocated 1 GB of memory, and you want to scale it based on the certain conditions. So you can write down your vertical pod autoscaler policy, and with the help of that it will adjust that. Then the third one is cluster autoscaler. So if by any chance your traffic goes higher, and you don't want to only increase the number of pods, but you also want to increase the number of nodes as well. So whenever you want to increase the number of worker nodes, you can use the cluster autoscaler concept. For that you can use the tools which are available for auto scaling, like Carpenter and others, and you can use that as well. Moving towards the fourth question, how do you debug Kubernetes pods? So that's the question which comes every time whenever you appear for any interview, in terms of cloud engineer or the DevOps engineer, platform engineer, or any development field as well. Like if you face any issue during your deployment, after the deployment, how will you start debugging? So for that you can go with the kubectl commands. First command, you can run kubectl logs to check the container logs or the pod logs. Whatever the error is coming, based on that you can do the troubleshooting. You can also go with the kubectl describe pod, so that you will see like what are all configuration you have passed, if there is any particular message coming while doing the describe. So you can check all the events and the recent status, whether it's failed or whether it's passed, correct, running in the running state, correct. Then you can do the kubectl exec command to open the interactive shell. With the help of that you can run your Linux command, and you can do the further troubleshooting. Like you can get into the container and you will be running your custom commands based on requirement. Or you can go with the kubectl get pods to list down all the pods which are with the status failed. Similarly, you can go with the kubectl events and kubectl get pods. All these kubectl command you can run and do the troubleshooting based on the requirement. Moving towards the fifth question, how do you perform rolling updates and rollbacks in Kubernetes? Like you have to deploy from one version to another version, how will you do that? Or if you have deployed on the next higher version, and if you have to come back because of any issues in the newer version, so how will you do the rollback as well? So you have to tell both the things. How will you perform rolling updates, or if there is any issue, how will you roll back your deployment? So K8 deployment supports rolling updates to avoid downtime. Like in the rolling update, what happens? Your pods goes one by one. Like the older pods goes one by one down, and the newer pod will come one by one up. Like if one newer pod comes up, the one older pod will go down. So it goes like one by one, so that your traffic will be distributed uh, horizontally, or you can say uniformly, so that your performance or the application will not see any kind of downtime or any slowness towards the application. So you can perform a rolling update by editing a deployment or explicitly setting its image to a new version. Whenever you will set a new version of the image, it will go for the rolling update, and your pod will start getting created for the newer version one by one. Correct. If you have to roll back your deployment, so you can use the kubectl rollout command, and then your deployment can be rolled back with the help of this. Next question is, what is an ingress in Kubernetes and how does it work? So ingress is a kind of API object that manages external HTTP or HTTPS access to services inside a Kubernetes cluster. It allows routing requests based on the hostname and path. So if you have a particular DNS and you have to route that particular request to any particular service, so ingress will help you to route your traffic to different services. Like if you see this YML file, you see that there is a host myapp.example.com. If there is a path forward slash or in slash abc, so based on that it will route to the actual service. Like on the my service it will route the traffic. So my abc.example.com request will come to this my service, and my service will further route it to the pod where your actual container or where your actual application is running. So that will return you the response. Correct. So this is how your ingress helps in the networking part. Next question is, how does Kubernetes handle resource limits and requests? So when we talk about the resource limits and request, we are talking about the CPU and memory. Like how much memory or CPU is required for any process to run or any container to run, which is running within the pod. So there might be multiple containers. There might be a single container within a single pod as well. So if you see, request and limits are for pods to ensure fair allocation and avoid the overuse of cluster resources. Requests are the minimum amount of CPU. If you see the pointer here, requests are the minimum amount of CPU and memory a pod needs. They are permanently assigned to pod. Like if you are requesting for zero point 0.5 GB of memory, 0.5 core of CPU, correct? Half of the core of CPU. So that will be permanently allocated for that particular process, while limit is the maximum one, correct? Like if you have 2 GB of limit, so you can assign that right now, as of now I need zero point 0.5 GB of memory, but if there is any requirement that it has to go higher, so you can define a limit as well. That means it can go up to the 2 GB, correct? So that you can define in the limit. If you see the YML file over here, in the pod there is a within the container configuration, there is a you can say the sex for the resources within which it's defined as a request and limit. So in the request, if you see, memory is 256 MB, while the limit is 512, correct? So the resource request is the one which can be set as a permanent, and the limited one, while limit is the maximum limit which can be consumed. So that's the difference between request and limit, and this can be defined for the different containers as well, which are running within your pods, correct? So within this pod there will be one container, then there will be different containers. So for each container you can define your request and limits. Okay. Moving towards the eighth question, where it went. What happens if a pod resource needs to grow beyond the assigned limits? Like that means if you have defined 500 MB of the limits, 512 MB of the memory, and your process needs more than this, whatever the limit you have defined. So what will happen? If it's related to memory, if you see the definition over here, if a pod's memory consumption exceeds its assigned memory, Kubernetes immediately kills. If you see this highlighted one, it immediately kills the container with an out of memory error. So whenever your requirement will exceed for the memory more than the limited one, which is the limit, it will result into the error out of memory and your container will get restart. While if this problem occurs for the CPU, it will not get restarted. If you see the line over here, it is not killed. Instead, Kubernetes throttles CPU usage, which will cause the slowness of the application. That means CPU will slow down your performance of the application, but it will not be killed. So your application will be running, but for the end user, it will be kind of slow. Okay. Now moving towards the ninth question. What are init containers and when should you use them? Init containers are special containers that run before the primary containers start. Like if you have a container where your main application is running, like your abc.com application is running, but before this abc.com application, you need any kind of secret which needs to be read and which will be utilized in your main container so that it will make the connectivity and it will run the application. So your init container will run first, it will fetch the secret and then it will help you to run the main container. So if you see the definition which is written over here as well, they help prepare the environment by checking the dependency, loading configuration files or setting up the data. One example could be an init container that waits for a database to be up and running. So here the init container is checking for the database to be up. Once the database will be up and running, your main container will get started, correct? It can be used for any purpose. Here it is being used for the database up. Last question and the 10th question, how does Kubernetes handle pod disruptions and high availability? So when we talk about the pod disruptions, we are talking about like what happens if my for a particular microservice, just suppose that there are 5 number of pods which are running and all these 5 number of pods are running in only one node. So if by any chance one node goes down, that particular specific node goes down, or your application will shut down, correct? So Kubernetes ensure that all the pods of a particular microservice should not go to only one node, but it should be distributed uniformly to the different nodes. So how that can be achieved? For that there is a pod disruptions budget. It ensures a minimum number of pods remain available during voluntary disruptions. Example, cluster updates where node needs to be scaled down. So when if even if there is a node is going down, this minimum number of pods will be available, correct? Then there is a concept of pod affinity and anti affinity, which controls for which pod can be scheduled together or separately. So whether you want to uh, all the pods should go to only one node or a specific node, or you want to distribute your pods to the different node. So that you can handle through the concept of pod affinity and anti affinity. Then there is a third option, node selectors and tents and tolerations. So what does this one do? It controls how workloads are distributed across node, correct? So if you want to see, there is a YML file and this YML file you can check here. Yeah, this is the YML file, the last one. API version, policy beyond, pod disruption budget, metadata and specification. So that one is there, correct? So this is all what I wanted to talk about, and stay tuned with the channel and subscribe to the channel for more such interview questions and DevOps related content on the AWS Cloud, Terraform, K8, CI/CD, and other tech stacks. Till the time, thank you. Bye bye.